Right, just a little background about Chapter 8, since you'll mainly be presenting and watching other presenters talk about most of the vitamins. Just a little introduction, though, about how they're absorbed and the difference between fat and water-soluble vitamins. So why do we need vitamins overall? So first of all, for fluid and electrolyte balance, that's going to keep our sodium, potassium, chloride, and phosphorus kind of in check. That keeps osmosis and movement of water in and out of our cells normal. Bone health is an important one. Of course, we think about vitamin C, or vitamin D and calcium for bone health, but also very important to bone health is vitamin C, phosphorus, fluoride. So again, a lot of our vitamins help with bone health. Brain health is one of the biggest ones, as you'll see here in our laundry list. Almost all of the vitamins that we're going to talk about today are needed to maintain our normal brain health. Blood health, so thinking about blood clotting, especially. So multiple vitamins are needed, as well as transporting oxygen. Our immune system relies heavily on vitamins. So typically if someone's getting a cold, we'll hear, take some extra vitamin C. And that's true, but a lot of other vitamins are important to good immune health. And finally, energy balance. So maintaining proper, ATP levels and cellular respiration in our mitochondria to keep all of our enzymes nice and healthy. So what is a vitamin? It's a carbon-containing substance that's needed in small amounts. So we don't need, it's not like calories that we're consuming large amounts of carbs or protein. So we have to have them. However, we just need them in small quantities. Vitamins are essential. Again, essential just means we can't make them. Since they can't be made by the body, we have to take them in our diet. So in order to be classified as a diet, the two main things, so again, the body can't make enough to maintain health. In the absence, and we're talking about a prolonged, not just missing a day, but a prolonged absence of that vitamin causes some type of deficiency, and that deficiency can be cured if putting the vitamin back into supply. Now we also, even though they are required, again, it's in small amounts, so we will talk about upper limits and upper levels, or what are referred to as mega doses, because some of them we can take too much and they can become toxic. And then our food or synthetic sources, again, have the same health benefits. So we'll talk a little bit at the end of the next one about supplements. So again, consuming within our foods are the most efficient way. All right, so our classifications, so vitamins are either fat soluble, meaning they don't dissolve in water, they need to dissolve in lipids, or they are water soluble. As you can see, the majority of them are water soluble. So if you can remember the fat soluble ones, the rest of them are water soluble. So the fat soluble are all vitamins. So we have A, D, E, and K. So those are all the fat soluble. So maybe come up with a mnemonic or something to help you remember those, make up a name out of them. But again, so you can remember the fat versus the water soluble. And then again, everything else we'll talk about are water soluble. So we'll be going through all of these, learning what their function is, and then what happens when we don't have enough of them. All right, so with our fat soluble, again, the main difference here, obviously how they dissolve, but also how they're stored. So fat solubles are going to be absorbed by the dietary fat. So instead of hanging out with all of the water, it's going to be transported and stored and kind of processed like our triglycerides and our fat molecules were. So anything that interferes with fat absorption will also impair fat soluble absorption. So different medications or things like that alter our fat absorption will limit the amount of fat soluble vitamins we can absorb. Now the water soluble, these are mainly going to be processed like the other foods that we've mainly talked about. So they're mainly absorbed in the small intestine, high bioavailability, which just means a lot of them get absorbed. So bioavailability is the percent that gets into the blood based on what was given. So if you take a vitamin C and all of it gets into the blood, that's 100% bioavailability. Now, once in there, they are transported to the liver using that hepatic portal vein, and then the liver distributes it into the blood, into the body tissues. Now, once they're inside of the cell, these active coenzymes can be remade. So often they are not activated until they're in the cell or into the liver. All right, again, we'll talk some about the vitamin toxicity, especially an issue with the fat solubles because they're going to hang out with our fat. They're not going with the water in our urine. So especially vitamins A, D, and E are not readily excreted, which means they can build up in the blood. So that toxicity, especially with vitamin A, is the one we talk the most about or worry the most about. Again, it gets stored in the fat. So if we keep consuming large amounts of them, it does store up and can cause some problems. Now, we don't really see this with water-soluble vitamins because they're excreted in the urine. So if we take more, we just excrete more. Now, the exception, though, to that is vitamin B6 and vitamin B12. And this is because they actually get stored in the liver instead of being metabolized and processed and excreted with the urine. It still happens, but it's stored. The liver stores these in larger quantities. So this is most frequently seen whenever supplemental sources are being used. So it's really hard to reach that upper level just by eating foods. We see these whenever vitamin supplements are taken and too much are taken, or they're taken in large quantities, which is called a megadose. So vitamin C, we see this a good bit, where vitamin C, it'll say 100% of the daily recommended value, but it's actually giving you 200 or 300% of what you need. And so people are like, oh, well, if 100% is good, then 200 is better. That's not necessarily the case. So that's what we refer to as a megadose. All right, so just a little bit here about preserving vitamins in foods. So the content is greatest whenever the fruits and vegetables are ripe. So if they're if they're not quite ripe, thinking like a banana or something like that, or a peach that's still really hard. So if they're not quite ripe, that indicates that they haven't reached their peak in producing vitamins. Freezing actually helps to retain the nutrients. So sometimes those are blanched first, which means they're just boiled real quickly. That increases the vitamin content, and then they can be frozen. So just understanding freezing doesn't denature or harm the vitamins. It does help preserve them. Now the water-soluble ones are particularly susceptible to destruction though. So again, boiling them, steaming, heating too much can actually destroy the vitamins, especially the water-soluble. Also exposure to light and air, again, cooking in water, and high pHs, so more basic pHs. All right, just looking here at the MyPlate sources as far as vitamins, and we'll also talk about choline. So essentially all of the food groups help provide some of our vitamins. So again, as long as we are consuming that recommended, all of the variety of foods in each of the food groups, then we are obtaining all of the vitamins that we need. It's whenever we're not consuming enough or not the right ones, that's whenever we start seeing those deficiencies.